for us, please?
And this, I would list that would all be negative.
They're both negative, yeah.
Okay. So it'd be -4, -6.
Yes, you got it. Very good. Okay. Any questions on that before we move on to the more difficult case? Okay, very good. All right, so let's look at a new problem here. Let's go x squared minus 5x minus 6. So it's the same rule. It's the same thing that we've been doing here. You have to find two numbers that multiply to the last, but add up to the middle. So that's -6.
So for this one, do you list a positive and a negative,
Exactly. Yeah.
like alternating?
Yes. Or if you don't like that, you only want to do one of them, you wait till you get the one with either the right sign or the opposite sign and then flip the signs. But these are by far the most difficult because you have to get your signs right.
Mhm.
Can you tell me what would go in parentheses here?
Only unsweetened one they have, but they didn't have any cold ones.
Thank you. Is this one -1 and +6?
Oh, I'm sorry.
This one, the one you just mentioned, adds up to +5.
Oh wait, never mind. I mean the 1 minus.
Yes. And that's where I was like, well, you can think you're right, you can think you're doing it okay, and you gotta be very careful here. So yeah, it's x plus 1, x minus 6. Is that okay?
Yeah, that makes sense.
All right, let's try another one here. Let's go x squared minus x minus 12. X squared minus x minus 12.
How would I do just a -x?
So you've got to look at it as there's a -1 there in front. So
Okay,
if it's not,
that's a 1.
yeah, if it's not written, it's a 1 or a -1 depending on the sign.
So I would do the same thing.
Yes. Yes.
So it would be -1 and 12. Then negative or +1, -12. Is it +3, -4?
Yes. X plus 3, x minus 4. So now real quick here, let's say I asked you to factor x squared plus x minus 12. How would your answers change?
Would you do the same thing, but you would usually end up with a negative and then a positive in the second one?
Yes. Yes. So the point is one is always positive, one is always negative. It's actually the same numbers though. It's a 3 and a 4. You just got to get the signage right on those.
So it would be a -3, +4.
Yes. Very good. Any questions on that? Okay, so that's the review of the first type of factoring. The next type of factoring we looked at are perfect square trinomials. So I'll give you an example of one here. X squared plus 6x plus 9. Now, if you treat this like a problem we have just done, you would try 1 and 9 and 3 and 3. Which of these add up to 6?
The 3 and 3.
Yes. Now, do you see that they are the same?
Mm-hmm.
So that's part of what makes this a perfect square trinomial. The answer is x plus 3, x plus 3. And then this is commonly written this way, x plus 3 squared. And the question might be, well, maybe there's a better way, especially if we know that the answers are the same. The number actually comes from this 9 right here. The square root of 9 is 3.
Okay, that makes
So-
sense.
So we'll see that in another problem here. Let's say it's like x squared plus 10x plus 25. You actually focus on that last number. What is the square root of 25?
It would be 5.
Be 5. So this becomes x plus 5 squared. So like you could come off to the side and be like, okay, 25, it's 1 and 25, 5 and 5. Oh yeah, it's 5 and 5 because that makes 10. And you could write, okay, x plus 5, x plus 5. But this is sort of a shortcut to get there.
Okay, that makes sense.
All right, so let's have you try one here. Let's say it's x squared plus 8x plus 16. Can you tell me what this factors to?
F4 and 4.
So x plus 4 squared like that.
Yeah, x plus 4 squared.
Okay. So now we moved to another type of problem here. The next type of problem is where there's a negative. So we might write something like this, like x squared minus 18x plus 81. Okay. Now, if you go back to how we were doing this problem earlier, you would write out all the factors of 81, 1 and 81, 3 and 27, 9 and 9. And you'd say to yourself, well, none of these add to negative 18. But if you make them both negative,
So you do the same thing?
yes, but now it's got a negative sign. So this becomes x minus 9, or x minus 9 squared. Let me know if
That makes sense.
got that down. All right, perfect. Okay, so let's look at another problem here. Let's go x squared. Which one have we not done? Minus 14x plus 49. What does this factor into?
And is this another perfect square?
It is, yeah, these are all perfect square trinomials.
Okay, let's see. 49. Seven and 7, but negative 7 and negative 7.
Yes, so x minus 7 squared like that. So notice similarly, I could give you x squared plus 14x plus 49, and that would be x plus 7 squared. Is that okay?
Mm-hmm.
All right. Now we transition to more complicated problems, something like this. 9x squared. Actually, I need to check my notes here and make some that work here. Plus 30x plus 25. Yeah, this does work. Okay. All right, so in a problem like this one, this is also a perfect square trinomial. You might be wondering, well, how would I even know that? If you can take the square root of the first and the square root of the last, it generally is a perfect square trinomial. And so can you take the square root of 9?
Yeah, 3.
3. So this is 3x. Can you take the square root of 25?
It's 5.
So you pair them together like this, and that is your answer.
How do you know when to do that?
It's a good question. There's a little bit more to it. For right now, I'm giving you all of these that are perfect square trinomials. So the answer is if you multiply 3x times 5 together and then double it, do you get 30x, which is the middle term? And in this case, you do. 2 times 3x is 6x, 6x times 5 is 30x, like that. So that to answer your question, that is how you know. Okay, let's try another one here. Let's say it's 4x squared plus 12x plus 9. So notice that you can take the square root of the first term and the square root of the last term. What does that become? What's the square root of
2
4?
and 3.
Yeah, so 2x plus 3 squared. Now you come off to the side here. Is 2x times 3 doubled? Does that equal 12x?
Yeah.
It does, yeah. You seem a little uncertain. Let's try another one here. 64x squared plus 112x plus 49. You want to try this one on your own?
Yeah, I'm not sure what the square root of 64 is.
It is 8.
So it would be 8 and 7.
Yes. So tell me what to write here though. Give me the full.
X plus 8 and x plus 7.
8x plus
Oh,
7 squared. Notice every time it's just the two things that we're taking the square root of go inside parentheses. I'm trying to find a few more that are different than the last ones we did. Here's another one here. 16x squared plus sorry, I'm just trying to get these that work here. 8x plus 1. Okay. Let's try this one. So can you take the square root of the first? Can you take the square root of the last?
Does 1 have a square root?
It does. The square root of 1 is 1.
Okay. So the square is 16. Is the square root of 16 4?
It is 4. And then what goes with it?
So 4x plus 1 squared.
Yes, you got it. So I'm trying desperately here to find a few more for us to work on. But I think we've got it. Let's say we've got it here. And let's move on to the next type of factoring. Okay, so the next type of factoring I'd like to show you is a difference of squares. I don't think we've done this, at least it wasn't in the last notes, might have been the one before that. Do you remember if we've done difference of squares?
I don't think so.
Okay, so difference of squares is the following. It would be something like this. It would be something like x squared minus 4. Okay. Now you have to rewrite this in such a way that you're writing something squared minus something squared to get back to the previous line. Okay, so on the left here, it's x, because x in parentheses squared is x squared. On the right here, 2 squared gets you back to 4. So you're gonna probably rewrite a bunch of these that we're gonna do today. Is that okay? Is that clear?
Kinda.
Okay, so now we're going to use a formula, a squared minus b squared. Okay, and this always becomes a minus b, a plus b. All right, and so in terms of your problem, in your problem, a is x and b is 2. It's the thing inside parentheses. So in your problem, you will write x minus 2, x plus 2. How does that look to your eye the first time you've seen it?
Weird.
Yes, okay, we like that. All right, let's do another one. X squared minus 25, okay? So you want to rewrite this as something squared minus something squared in parentheses, okay? So on the left it's x. On the left it's x squared. On the right, what squared gets you back to 25?
I'm not 15. No.
5. So the answer to this is it's the square root of 25,
Oh,
just like we
yeah.
were doing the previous problem. So now I'll write the formula again here. A squared minus b squared becomes a minus b, a plus b. So this becomes x minus 5, x plus 5.
Okay. And what do you do after that?
That's it. That's what you need to be able, like we're trying to get you to be able to write this. So just like in the earlier problems, when it was like, well, what do you write? You need to write the 2 pairs, like x minus 3, x plus 4 for this one. For these, it's going to be x minus 5, x plus 5.
Okay.
All right, so let's have you try one. How about this one? X squared minus 36.
And that one was 8, right? No, 6. No.
Are you asking what the square root of 36 is?
Yeah.
It is 6.
Okay, 6. That's right. So it would be x minus 6, x plus 6.
Yes. Little hesitation, but you're doing it perfect. How about x squared minus 1?
Would that just be x plus 1?
Let's say that one more time.
Would that just be x minus 1, x plus 1?
Yes. How about x? Actually, let me change this up here. Let's say I give you 9 minus x squared. Okay.
Would I read that as a 1?
No, it's a 9. So it's like
Oh.
what squared minus what squared?
3. Yeah.
3. So your a is 3 this time. And you still always write it as a minus b, A plus B.
So how would I write that exactly? So I would write that like that.
3 minus X, 3 plus X.
Okay. So the same?
Well, whichever one comes first. So if the number comes first, you
Oh
write the
yes,
number.
the X or the number.
Yeah, whichever,
Okay.
because it could go either way.
Okay, that makes sense. If the number's first, then it'll be like 3 minus X, but if
Yes.
if it was the other way around, it would be X minus 3.
Yeah, so let's try another one here. How about 81 minus X squared?
Mm, So it would be 9 minus X, 9 plus X.
You got it. Yep,
Can I run to the bathroom real fast?
sure.
All right.
All right, so a couple more problems like this to work on. So let's start here. The next type of problem I give you something like this: X squared minus 9 Y squared. So what's different about this problem is that I can introduce more than one variable. Okay, but it's still the same approach. It's that X is being squared and that something is being squared to get you back to 9Y squared. And it's the square root of 9, which is 3, and it's the square root of Y squared, which is Y. So it's, again, it's still A squared minus B squared. Your A is X and your B is 3Y. So you'd write this as X minus 3Y, X plus 3Y, like that. Does that make sense?
I think so.
Okay.
It's
Right.
just it depends on if there's another variable tacked onto it.
Yeah. Now you're probably not going to see one with two variables. So let me back off that. You're probably going to see something more like this. 4x squared minus 25. So you got to figure out what squared minus what squared gets you back to the previous line.
Oh, so it's like a 2 of them?
Yes. So how do you get back to 4? What is the square root of 4?
2,
2, and then the x, and then the 25.
5.
Yes. Okay, so now this becomes what times what?
I'm not sure.
So it's the 2x minus the 5, the 2x plus the 5. Like the whole point of
Okay.
rewriting it is to get the a and the b. So the a or the b could be more than one thing. Like it's not always just a number or just a letter, it could be a mixture. Let's try another one here. How about 9x squared minus 49. 49. So it's
Mm,
what squared minus what squared?
49 was 7, right?
That's right.
And then 3.
3x.
So it would be 3x minus 7, 3x plus 7.
Yes. All right, I think you've got enough here for us to actually simplify some rational expressions, which is based on factoring, which is the whole reason we were learning this to begin with. So sometimes we get so far down the road, it's like why are we even learning this? So let's look at something here. This will be a little bit of review as well. Any questions on what we've done before we move on to related stuff? Okay. All right, here we go. So this problem says to simplify. Okay, and what they really mean is you need to factor. Now there's a bunch of different types of factoring. GCF, difference of squares, which we just did. Perfect square trinomial, which we did today. And then the A equal 1 that we did today. There are more, but that's probably enough for us for the moment. Okay, so you always start with GCF. You're always like, okay, let me see if there's a GCF. When you look at 2x plus 6, is there a number that goes into both 2x and 6?
2.
2. So this top one becomes 2 times, and what goes in parentheses? What do you write in here such that when you multiply in, you get back to 2x plus 6?
I'm not sure how you would write it.
Okay, so here, let me help you out here. What happens when you divide both of these by 2? And we have done this before. I know it's probably been a couple weeks. We've done this before. You divide each of these by the thing that goes on the outside.
Would that be 1x plus 3?
Yes. Very good. Now we're going to do the same thing on the bottom. Is there a number that goes into both 4x and 12?
4
4.
and 2?
4.
Uh,
4 for sure.
Or just
You want
4?
you want the largest number. Now you divide both of them
Okay.
by 4.
So it would be x and 4.
X minus 3.
3. Oh.
Okay.
Oh yeah, okay, because it's dividing both of them.
Yes. Okay.
I was still thinking about the simplifying when we were doing this.
It's okay. We're kind of doing we're doing synthesis now. We're combining a ton of stuff. It kind of all culminates into this. So can you cancel x plus 3 and x minus 3? The answer is no. They have to be exactly the same. Exactly the same. All right. But can you do something with the 2 and the 4?
I don't know.
You can divide them. Yes. Like 2 and 4 can be divided. So it becomes 1/2. Okay. Let me back up here. I'm sensing this is not clear. So let me try something different here. All right, let's look at a totally different problem. More in line with what we've been doing. I thought the GCF you'd be like, oh yeah, that's GCF. So we'll do some practice with GCF, but let's work on some problems like what we've been doing today. All right, now I know this one looks more complicated, but it's essentially 2 problems that you've already done. It's essentially a factor and a factor. Okay, so if you need to, you want to just go ahead and rewrite one of them, like the top one here. And we did problems like this earlier today. Okay, you're trying to find 2 numbers that multiply to 6 but add to -5. Do you remember us doing some problems like that earlier today?
Mhm.
What would that be? Two numbers that multiply to 6 but add to -5. They are both negative in this case.
1 minus 6 or 1 and -6.
So they're both negative, or they're
Well,
both
yeah,
positive.
because it's one of them's only one's negative.
Yes.
So, 3 and 2.
-3 and -2.
Yeah.
So this becomes x minus 2, x minus 3. So the numerator becomes x minus 2, x minus 3. Is that clear?
I think so.
Okay. So the bottom, you have to do the same thing. I know this is like, it feels like it's really different, but it's just combining two problems that we did earlier. So this one, you have to find two numbers that multiply to -15, but add to +2. Can you try that for me, please?
Yeah, I'm doing that. Oh, so if the last one's a negative, you do the alternating.
Yes, that's right.
Just -3 and 5.
Yes, x minus 3, x plus 5. So the denominator becomes x minus 3, x plus 5. This is the fun part. This is the part where you do all the hard work and now you get to see some cancellation. So do you see that there's an x minus 3 in both the top and the bottom?
Mm-hmm.
Those can be divided or canceled out. So when you cancel them, they're just gone. You rewrite it as x minus 2 over x plus 5. I'm going to take your silence as maybe just uncertainty here. Keep in mind that the top and the bottom are just like two problems we did earlier. So you're just going to you're going to apply the techniques we've been using, one to the top, one to the bottom, and then hopefully you see some cancellations. All right, so let's try another one here. Let's do something. Let's maybe make this a little bit easier. Let's go x squared minus 9 over x squared minus 2x minus 3.
How would I start this one?
So let's look at the top. Let's look at x squared minus 9. This is a difference of squares. So you write this as something squared minus something squared.
3.
3. Yep. Very good. So it becomes x minus 3, x plus 3. So that's the top. Now on the bottom, x squared minus 2x minus 3, you're looking for two numbers that multiply to -3 but add to -2. Do you want to give that a try for me, please?
So would it be -3 and 1?
Yes. So it becomes x minus 3, x plus 1. And that goes on the bottom. X minus 3, x plus 1. Do you see any cancellations?
Yeah, the top, the first one.
Yes. All right, so your final answer is x plus 3 over x plus 1.
Okay.
Let me know when you're ready for us to try another one.
Yeah.
Okay. Let's go x squared plus 2x plus 1 over x squared minus x minus 2.
Do I do the same thing with the top and bottom?
Yes. Yes, you have to factor each of them individually. And I've been switching them up each time. So if you're not sure, you have questions, please ask. Or if you like, I'd like you to try the top first and we'll talk about that one.
Is that 1?
So it is x plus 1, x plus 1. It's a perfect square trinomial. How about the bottom? How about x squared minus 1x minus 2?
Would that be 1 -2?
Yes. X minus, I'm sorry. You said 1 and -2? I think I heard.
I think so, yeah.
Yeah. Okay. Do you see any cancellations?
Can you only cancel one set, the first one?
That's right. So your final answer here is x plus 1 over x minus 2. Let me know when you're ready for another one here.
I'm ready.
All right. Let's go x squared minus 6x plus 9 over x squared minus 9.
Mm,
Any, do you need any help, anything here?
It's the first one, the -3 and -3.
Yes.
And then what do you do for the bottom one again?
Bottom one is difference of squares. Does that at all help to hear that, or is that still not helpful?
How do you write it again?
So you're looking for something squared minus something squared.
3?
So x and 3, and then do you remember how to write it after you?
Mm-mm.
So it becomes x minus 3, x plus 3.
Okay.
And again, there's some cancellations. There should be. That's the whole point of this type of problem, is something cancels. Okay, let's try another one here. Let's go x squared minus 25 over x squared minus 4x minus 5.
Would the first one be -5x plus 5?
Yes.
And then the other one would be -5 plus 1.
Yes. Like this. You can see that they cancel there. And you're left with x plus 5 over x plus 1. Do you want to do one more tonight?
Yeah.
All right, let's do it. Let's go x squared minus 8x plus 16 over x squared minus 16.
So would the first one be x -4 x -4?
Good. Yep.
And then the bottom one would be x -4 x plus 4.
Yes. And so they cancel. And that is it. That gets you x minus 4 over x plus 4. So I'm just going to make a note here that next time we should work on GCF factoring
Mm-hmm.
and then continue on with these types of problems. So, all right,
Okay, that makes
I'm
sense.
going to go ahead and stop the recording